Hi there. Today I'll be giving my presentation on my ethology project that focuses on the seconds it takes a Calipitiana Chortullidae to move from one flower to the next. Here's some background information on a couple of topics that describe and will hopefully get you a bit more familiar with Calipitiana if you aren't already. This Chortullidae scientific name is Calipitiana. The phylum that it falls under is the Chordata, the class Aves, the order Ophidiormes, and the family Hummingbird. So to start off, there are known to be 349 species of Chortullidae. As you can see here in this image, not all 349 species of Chortullidae show here, but you can get an idea. And of course, the Calipitiana is one of them. As we all may know, the Chortullidae are most commonly known as hummingbirds. Calipitiana are known to most commonly be in California, deserts of Arizona, and Mexico. You can see the color coordination of the map. They were known to only be more active in areas of Baja California. Again, on the map it shows. But in the 1930s, they began to expand their range. And the areas were like southern Arizona, British Columbia, and Vancouver Island. The Calipitiana is a small bird that settles in very greenery vegetation that includes things like trees, bushes, and grass. All Chortullidae, although having a small body, it definitely does not stop them from having such a rapid movability and hovering motion. A way you may wonder to identify a male from a female would be the colors they carry. As you can see here, it would be the colors they carry on what is called their gorget and also their head. As you can see here, males have their face and gorget filled with vibrant colors, as you can tell here in this image of a male. When the female Calipitiana, on the other hand, right here, have no vibrance of color whatsoever, not even on their face or their gorget. It's just mostly on the back. And you can tell here, the Chortullidae are viviparous because they lay eggs. They also reproduce, and nesting occurs between winter and early spring. Cool fact is that they only lay 2 eggs. I thought that was interesting. As for their food source, they consume nectar, small insects, and spiders. Chortullidae burn off energy by fast flurry movement, nesting, and finding their food source. And of course, by the making of their hovering motion. This now makes nectar their most important food source because it includes the sugars a Chortullidae needs on a daily basis. The sugar that the nectar gives off to the Chortullidae results in high rates of aerobiotic energy, metabolism, and flight muscles. Here is a video I will be showing where not necessarily it shows when they're feeding on a flower, but it just shows how fast they move and their hovering motion.
Starting to think he's a psychopath.
You can see some are hovering and then others just move fast. Go back. So this now eventually leads me to my question and how my experiment started. My question was, is it possible for Trochilidale to consume that exact amount of nectar it needs from different flowers? My experiment question was, how long do they feed on a flower before moving on to the next? My hypothesis was, if the Trochilidale are feeding off the nectar from multiple flowers, then it will take 15 seconds from them to move from onto one flower then to the next. My prediction was that it will potentially take a Trochilidale 15 seconds to move from one flower to the next. Collection of data began on April 5th, 2021 through April 10th of 2021. The location was outside my home deck, right here. This is not my deck, but this is the only best thing I could find as an interpretation of a deck. I had a few more, you can just imagine if this was my deck, I had a few more flowers here, which was what attracted my hummingbird to come between the times of 4 p.m. and 6 p.m. I decided to take this time into consideration and begin my experiment during this time, because a few days before I noticed that between 4 p.m. and 6 p.m. was the time where they would come a little bit more often. And my guess was because there wasn't enough like, what do you call it? Like distractions for them, or things that would distract them or scare them off from coming down and consuming nectar. Some tools I used was the window view of course, my home, a chair, a stopwatch on my iPhone, a copy of my data table to collect all my data, a field notebook to take other notes, and pen and pencil. Here is my data results indicating the observation date, observation hour, and the observation of Trochilidae that arrived on the deck. I had potentially made a data table with 6 open spaces for the Trochilidae to come, for the Trochilidae time collection, but only 4 arrived. Monday through Tuesday, as you can see here, were my consecutive days, and making Thursday and Saturday my next 2 days where I collected data. This scatter plot is a representation of my data table results. At the top of this scatter plot is the title, a title that gives off an example of the experiment I was trying to reach out for. The y-axis indicates the times right here, and the x-axis displays the times each data was collected. You can see the color dots represent each and one of all of the 4 Trochilidae that arrive to my deck, and giving them each their own color to be able to identify who did what on what day. My hypothesis as a result was not supported, given the fact that the overall rate of seconds it took for the Trochilidae to feed off nectar from a flower before moving on to the next was between 8 to 28 seconds. My hypothesis was it would only take 50 seconds for the Trochilidae to feed off nectar from a flower before moving on to the next. In conclusion, that Trochilidae or nectar consummation time can be either a very short or a long time, and not just from one flower, because they don't just, I believe that they don't get all their consumption of nectar from one flower. There was a few errors that I believe I did on my part that could have been improved to succeed in this project. And it was to possibly just have a better view, because my window was a little bit slanted, but I didn't want to do a lot of movement to not distract them from that, because they just get really distracted with just a little bit of noise. Like, I have a dog and sometimes he would bark, and just that bark noise would like distract them out of all the places. And I think all those errors could have, for the next time, could be adjusted and definitely could help me to have a better, successful and more entertaining study. That is my project. Thank you.